For centuries, the global economy relied on wooden ships sailing thousands of miles across the open ocean. The crews took on these dangerous voyages for the staggering payouts waiting at the end, hauling incredibly dense, valuable cargo like black pepper and exotic spices from places like Kerala. But the entire system hinged on a serious physical vulnerability. To figure out where they were going, early sailors had to use the stars to plot their course. If a storm rolled in, or an overcast sky obscured the heavens for days on end, a crew could find themselves completely blind, drifting off course with no way to reorient. The answer to this maritime crisis came from a peculiar, naturally occurring rock called a lodestone. This mineral possessed a strange, invisible force that could pull specific metals right to its surface. To solve the greatest bottleneck in global trade, humanity had to stop looking up at the sky and start deciphering the terrestrial forces hidden right in the dirt. That invisible force is highly selective. A magnet doesn't pull on just anything. It only interacts with specific metals, primarily iron, cobalt, and nickel. If you want to actually see this force at work, you can map it by scattering tiny iron filings around a bar magnet. The metal shavings instantly snap to the areas where the pull is the strongest. Those points of concentrated energy at the extreme ends are what we call the magnet's north and south poles. But a strict rule governs these poles. You cannot isolate them. Snapping that bar magnet down the middle doesn't give you a separate north and south. You instantly get two brand new magnets, each with opposing poles. Magnetism is an intrinsic structural property of the metal itself. You can shatter the physical object into a million pieces, but you can never break the dual-pole nature of the force. When two of these magnets interact, they follow predictable laws. Bring opposite poles together, and they pull toward each other. Try to force two identical poles together, and they push each other away. This pushing action is actually the ultimate test for magnetism, because a standard piece of iron will stick to either end of a magnet. Only the act of physical repulsion proves that an unknown object is a magnet itself. And this behavior is exactly how navigators solved their crisis. The Earth generates its own massive magnetic field. If you suspend a small magnet so it can move freely, it will always get pushed and pulled until it aligns perfectly north to south. Ancient sailors figured out how to artificially transfer this power. By repeatedly rubbing a permanent magnet along a standard iron needle in one direction, they could align the metal's internal structure and turn the needle into a temporary magnet. To eliminate friction and let the needle spin, early navigators, like those using the Indian Matsya yantra, floated their magnetized iron in a vessel of oil or water. Combine a magnetized needle with a frictionless surface, and you get the ultimate maritime tool, the compass. By harnessing physical laws instead of relying on clear skies, navigators decoupled long-distance travel from the weather, securing a permanent, reliable way to traverse the globe. With a reliable way to find direction, ships could map coastlines with precision and cross vast oceans without getting lost, unleashing an explosion of global trade and accurate cartography. Today, magnets have migrated from the decks of wooden ships into almost every piece of technology we own, securing our bag clasps and driving the cones in our audio speakers. We've even scaled up the force of repulsion to eliminate friction entirely, levitating massive passenger trains right above their tracks. But despite their incredible lifting capacity, permanent magnets hold a physical weakness. Down at the molecular level, their internal alignment is remarkably fragile. If you expose a permanent magnet to extreme heat, drop it from a significant height, or hit it with blunt concussive force, you will scramble its molecular structure and destroy its magnetic field. The invisible pull of the lodestone literally mapped our modern interconnected world, but the physical magnets themselves still require careful handling to keep their directional magic intact.